So this one, we describe the ways in which a force may change the motion of the body, apply Newton's law, and this is emphasizing on Newton's second law. So Newton's second law is here. So the Newton's second law of motion states that for an object with constant mass, the external force acting on the object is equal to the product of its mass and acceleration. 4 lines, just to say this, F equals to ma. Then force is in newtons, mass is in kilograms, acceleration is in meters per second squared. You need to know how to write this in full, unfortunately. Same as the first law, you need to know how to write it in full. Word for word, line by line. Okay, so this is more of a calculation section. They also may ask you, what is 1 Newton? I say please define what is 1 Newton. Then you will say that 1 Newton of force, it is the 1 Newton of force exerted on an object of mass 1 kilogram that produces an acceleration of 1 meters per second squared. This is also word for word. However, they can change this question into define 10 newtons. They can change this to
Newtons is the force exerted on an object of mass 10 kg.
no, mass 1 kilogram.
Or mass 1 kilogram that produces an acceleration of 10 meters per second square.
Yeah. Something like that. Okay, question 1. A car has a mass of 2.0 times 10 to the power 3 kilograms. Then the resultant force created by the engine is 3 times 10 to the power 3 Newton. Calculate the acceleration caused by this force. So number one thing I will do is I will write down given what info? Given mass equals to 2.0 times 10 to the power 3 kg. And then force, resultant force is 3.0 times 10 to the power 3 Newton. Then they say calculate acceleration. So like that, I digest the question in this manner. So I want to find acceleration. Step 1. Step 2, I would then look for a formula that involves mass, force, and acceleration.
F equals ma.
So then I'll write down F net equals to m times a. Then third step, insert all the numbers. Equals to 2.0 times 10 to the power 3 times a.
3.0 times 10 power 3 divided by 3.0 times 10 power 3.
Yeah, then write unit like that. What is the answer?
1.5.
Let's check. Yep, part 2. So now what should you do? You may need a drawing. What is the working?
Constant speed means that forces must be equal.
So if you have an MCQ question, you can do it like that. You can use iPower and then answer comes out. We all know what's the reason and you don't have to show working. But if it's a structured question, then they have all reasons to ask you to give a working. And they can label 2 marks like that. Then you're going to run into some issues because you gave them the answer. So you only get awarded an answer mark. So I would draw, say, friction and then the applied force. The applied force is 50 newtons, like that. So then constant speed, so acceleration is 0. So we'll get resultant force is mass times acceleration. So resultant force here is actually 50 minus F. So mass is 10, acceleration is 0. You do this. Then if they want you to give a proper working, then this is the proper working. So you give them a diagram, show that the resultant force is applied force minus friction. Take note, shall we? This is easy. We've done this multiple times. So now I have 2 forces on an object. Then you say calculate the resultant force. So equals to 150 minus 100 equals to 50 newtons down. Second, so this one, calculate the resultant force. There will be 2 resultant force, one in the horizontal direction and one in the vertical direction. 40 down, resultant force 40 down. 0 left, right? Is it 40 down?
40 up.
Upwards more than downwards, so it's supposed to be 40 upwards. See, 40 upwards. This is a reverse question. This is a reverse question. Says a draw and state the magnitude of another force acting on the object to give a resultant of 40 newtons as indicated on the diagram. So you draw a force which is towards the right, 60 Newton force to the right. Okay, good. My answer got no answer. It's towards the right. This is correct. This one, calculation question. Now the question is bigger. You have to read the question and then break down what information you have from the question and then write the formula that is required and then the final answer. You cannot use F minus F equals to MA because applied force and frictional force is a different force. So one of them should be capital and one of them should be small letter to make sure that they are different. So given mass is 5.0, okay, force is 20.0 Newton. Friction is 12.0 Newton. Okay, then find A. F minus F equals to MA, correct? Math. Okay, wonderful. Here we have another one. So same goes if you have a question, if you see a question, that means we are supposed to do it and then I'm supposed to go through because this is not a new topic. Then when you don't know, you just tell me. Yeah, stuck with them. Yeah, that was correct. So maximum force is 6P. So your result in one is 6P newtons. Then you are supposed to calculate the mass of the acceleration of the truck when it carries a load that is half of its mass. We calculate. So you try it, then we go through. You may want to draw a diagram. It may help you. So you have the truck with mass P, then it carries a load half of its mass. That means it carries another box of itself, half P. Then they ask for the acceleration equals to how much. So the force on the engine is 6P. F equals to, so the total mass right now is 3/2P. So then you do resultant force equals to mass times acceleration. So this is the new mass. This is the force by the engine. And then this is the new acceleration you want to find. You want to make some changes? Yeah, yes. So you change that one. Okay, let's check. Yes. Okay, everything is fine. So you have a summary about balance forces. So you have a summary about balance forces. So what this chart tells you is that if the force is balanced, that means resultant force is 0. So resultant force is 0. Then the object in the question, right, will have 0 acceleration. So when it has 0 acceleration, the object, there will be two outcomes to the object. So the object will be stationary, means it's not moving. So the speed is 0. Or it can move with a constant speed because this one acceleration is 0. In these two cases, acceleration up to 0. So when your question has a story like this, then you approach it in this manner. Just calculation is always resultant force equals to 0. Okay, yeah, again, I deliberately make it into a slide where you can just print out and refer as notes, like some summary cards where you can, if you want, you can print out and revise. Then there's another one, which is the unbalanced forces. So unbalanced forces means resultant force is not 0. So if it's not 0, that means we know this, like over and over again, we repeat this. So because this is not 0, then you have an acceleration. So the acceleration can be affected by the mass of the object, and it can also affect the resultant force or vice versa. So it's two-way. So you have to take note about this one.